Hierarchical clustering. Hierarchical clustering is an unsupervised learning algorithm that builds a hierarchy of clusters. It starts with each data point as its own cluster and then merges or splits clusters based on distance measures, forming a tree like structure called a dendrogram. The hierarchy can be used to choose a suitable number of clusters by cutting the tree at a specific level. Let's go ahead and implement the hierarchical clustering algorithm and visualizing it with a dendrogram in Python. So I'm going to open an empty blank file and start with importing the necessary libraries. First, I need dendrogram and linkage from scipy.cluster.hierarchy. This imports the dendrogram and linkage functions from scipy.cluster.hierarchy module. Now the linkage performs hierarchical or agglomerative clustering, whereas dendrogram generates a dendrogram plot to visualize the hierarchical clustering. Next, import matplotlib pyplot as plot, which imports the matplotlib.pyplot, which provides functions for plotting graphs and visualizations. It is commonly used for visualizing data in Python. Next, we are going to import numpy as np, which imports the numpy library, which is essential for handling arrays and performing numerical operations in Python. Next, let's get some sample data similar to the last example that we had, where we are taking points in 2D space, np.array, which is equal to x. Now that defines the feature data x as a numpy array, where each sublist represents a data point in 2D space with two values, x and y coordinates. For example, 1, 2 and 10, 2 are 2 points in 2D space. The shape of x is 6, 2, indicating 6 data points with 2 features each. Now let's go perform hierarchical or agglomerative clustering. This can be done by z equal to linkage, pass it x, and method equal to ward. Now ward minimizes variance with clusters. What it does is this function performs hierarchical clustering on x and returns the hierarchical clustering result in the variable z. Now x here is the data points to be clustered, and method equal to ward specifies the linkage criterion. Here, ward is used, which minimizes the variance within clusters at each step, resulting in a compact and spherical clusters. Other linkage methods include single, complete, and average, which calculates distance between clusters in different ways. And finally, Z stores the results of the clustering process as an array, where each row represents a merge containing information on the clusters that were merged, the distance between them, and the number of original data points in the newly formed cluster. So let's go ahead and plot our dendrogram. First, plt.figure fig size 8,4. This creates a new figure for the plot with a specific size of 8 by 4 inches, which makes the dendrogram more readable. Next, I'm saying dendrogram z. This plots the dendrogram using the hierarchical clustering results z. The dendrogram visually represents the merging process of clusters, where each U-shaped link shows the distance at which clusters were merged. The x-axis displays the individual data points, and the y-axis shows the distance between merged clusters. Now I'm going to give a title to this. I'm going to say dendrogram for hierarchical clustering. Next, I'm going to give an x label, which is data points. This sets the label for the x-axis. And next, y label, I'll say distance, sets the label for y-axis. And finally, I'll say plot.show. This displays the dendrogram plot visualizing the hierarchical clustering process. The height of each merged y-axis indicates the distance between clusters, and cutting the dendrogram at different levels can yield different number of clusters. Let's look at it in real time of how it looks like. I'm going to go ahead and say Python hierarchical clustering, run it, and here you go. Here is our dendrogram. If you see, it has all these U-shaped based on the merging and clusters that it created. So this is how a dendrogram looks like if you have never seen one before. Now this code here performs hierarchical clustering on a set of 2D points and visualizes the results with the dendrogram, as you saw, which shows how clusters are formed by merging data points and group step by step. The dendrogram allows you to identify a suitable number of clusters by selecting a threshold distance. So I hope you were able to implement it. If you had any issues or problems or have any questions, let me know and I'll get back to you.